Assalamualaikum. Today me and my partner Iqbal will present about application linear algebra in electrical circuit. So let's get started.
First, let me introduce myself. My name is Muhammad Haziq bin Radwan. I'm 20 and I am from Selangor.
Hi, Assalamualaikum. My name is Muhammad Iqbal, and I come from Kuala Lumpur, and I live in Kajang, Selangor, and I am 23 years old.
So for the introduction, I will show you the definition of electrical circuit in linear algebra. Linear algebra most apparently uses by electrical engineers to solve any kind of problem in electric circuit. Wherever there is system of linear equation arises, the concept of linear algebra, as most people know that many electrical circuits solution like Kirchhoff law and Ohm law are conceptually arise linear algebra. To solve any kind of linear equation, we need to introduce the concept of linear algebra. By using Gaussian elimination, not only computer engineers but most of daily computational work minimized. So we don't have to use any extremely large number of pages to calculate complex system of linear algebra. So with the linear algebra, we can solve many problems, not only in math or calculation. Also, we can use it in some engineering workings. So it make engineers easier to solve some problems in in these modern days. First, let me show you about what is electrical circuit. Today, more than ever, electronics are integral part of our everyday lives. They contribute to every aspect of our way of life, lighting the space around our work environments, to exploring uncharted territories, but behind each and every electrical appliance or device, no matter what task it was designed for, lies a vast system of electrical components that must function as a whole. Each component, resistor, capacitors, inductors, and many more, has specification of their own, as does the final product that they are part of. So engineers must design their devices to meet not only their intended purpose, but so that individual components are within their tolerances. Vital to this is analysis of currents throughout the electric circuit. Let me show you an example. Simple or parallel circuits. So for simple circuits, such those used in math textbook, introduce system of equations. It is often sufficient to use series and parallel relationship to simplify circuits. As you can see, the calculation here with this done, Ohm law VRI can be used to find voltage currents. So as you can see at the in this slide, we want to show how to get a sufficient or a, a suitable voltage for some electrical circuit. As you can see, we replace Vs to Vt voltage. So and then we make some equation to make sure we get every circuit or currents to get it right at every current voltage. So larger circuits though are problem, systematic is no longer efficient. It becomes far too time consuming to analyze and reduce circuit. Instead, a new method of determining voltages and current is used called nodal voltage analysis and loop current analysis. We are going through our study case problem statement. This study case project received a problem faced by one engineer to calculate the output and input voltage from the complex electric circuit in small factory, plus engineer facing the overuse voltage during the working, and contractor overestimate voltage readings because inefficiency of circuit. From the electrical circuit, you can get several devices such as fans, air conditioning, lights, and any kind of machinery. The engineer also changes that kind of device to resistance in the electric circuit plan, so calculation and adjustment will be working on easier. So in this problem statement, we want to help the engineer to calculate the must use voltage in electrical circuit in this factory. So the area of our study is called Subang Bestari, which is situated in Selangor. It is one of the busiest cities in the state that have many factories and development activities in Subang Bestari. Then there are many electrical circuit engineers in the city to prevent short circuits from happening or anything else. But there are still many cases of overuse voltage during the working day faced by some factories. Then this causes the circuit not work more efficiently. Also, the engineer had to calculate input and output of voltage. This will cause factory workers to overestimate the voltage readings and cause electricity costs to increase. So our objective of study is to improve the calculation of voltage usage, to calculate the input or output or total usage that need to be used in a circuit, and lastly we want to improve electric circuits in factories.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I am a second presenter, and my name is Muhammad Iqbal. Next we move to methodology. For the first method, we use nodal voltage analysis and loop currency analysis. Using nodal or loop analysis, we end up with a system of equation with unknown variables. By simplifying and manipulating this equation, eventually all the unknowns will be solved, assuming there were the same number of equations as there were unknowns. This method too has the pitfalls, as circuits with many loops and nodes will require many substitutions, not to mention the large task of keeping track of all the variables. As you can see for picture for the left side, we collect data from a electric circuit and form a matrix. For the second method, engineer will using a Gaussian elimination to fix the problem of dealing with all the bookkeeping of variables. A simple change of notation required, that is to place the equation into a matrix form. Since the columns of the same variable, it is easy to see that row operation can be done to solve for the equation. This method is known as a Gaussian elimination. Now, for the last circuits, that will still be a long process to reduce the echelon form, but it's a no fact that computers love matrices. With the help of a computer and the right software, ridiculously large circuits consisting of hundreds of thousands of components can be analyzed in a relatively short span of time. Today's computer can perform billions of operations a second and reach the development in parallel processing analysis of larger and larger electrical systems in a short time frame every feasible. Okay, next we move to the result. From this slide was include the solution for engineer to fix the problems about circuits they face at their factory. As we discussed before, engineers are using nodal voltage analysis using Gaussian elimination method. As you can see from the slide, there are a plan of circuits picture set up by engineer. Next, engineer collect the data and form a equation. For the first step, engineer will form a equation from the plan. For the first equation is 1/30 plus 1/5 plus 1/10 times V1 minus 1/10 times V3 equals to 20. Okay, for the second question is negative 1 over 10 times v1 plus 1 over 10 plus 1 over 10 plus 1 over 20 times v3 equals to 5. Next, engineer will simplify them to, for the first equation, 1 over 3 times v1 minus 1 over 10 times v3 equals to 20. For the second equation is negative 1 over 10 times v1 plus 1 over 4 times v3 equals to 5. Then engineer will form a augmented matrix, as you can see from the slide. Next, engineer will reduce the matrix to shown form. From that, the engineer will get V1 equals to 75 and voltage 3 equals to 50.
So in this project, the engineers are trying to solve the problem how much usage or voltage can be used in electrical circuit. Also, and then by doing that, we use Gaussian elimination to determine how much input or output of voltage need to be used in electrical circuit. Also, we are trying to improve or fix the electrical circuit that had been damaged or had been calculated by the engineers in the electrical circuit. And also we can also, if they have fixed the electrical circuit or improve the electrical circuit, they also can increasing manufacturing products in all the factories. Hence, they can also increase our country economics by cost of mass manufacturing production in our country. Thank you and see you again.